Hello everyone, myself Himanshu Dhupia. So today we are going to talk about the types of rocks, and in this also we will focus more on the igneous rocks. So I welcome you all at the Universal Group of Institutions Bangalore, and our admissions are open for 2025-2026 session. So we are offering integrated courses along with the example being PUC along with the CLAT, CSET and CUT courses. In BCom, we are offering CA along with IAS, IPS and KAS examinations, and in BSc and BA, we are offering you IAS, IP and KAS preparation, and this year we are beginning a new course, MA Political Science. So go check out at universalinstitutions.com, or you can visit our campus also. And if you put referral code HIM007 during an admission process, you will get an interesting discount also. So what we have done so far, if we do a recap, that in previous videos I have talked about the rock cycles. So you already know what is rock cycle. That rock cycle is a series of processes that create and transform the types of rocks in earth crust. This is the rock cycle. Okay, this is the full picture. I have already told you about this particular lecture in my previous videos, so go check that out. Okay, so if I talk about how the rock cycle was affected by human activities plus environmental phenomenon, so these are all the phenomena like Earth's heat, caused by the tectonic process. We can say the large depth bodies of water, or we can say the precipitation, temperature and plant roots, or extraction of rocks by humans, in the pursuit of coal, petroleum and natural gas, and hydraulic fracking also. So I have talked all these things in this particular video, rock cycle. So please go check that out, and for such videos, make sure you subscribe the channel and keep the notification bell icon on, so that the moment we post any video, you will get the first. Okay, so now today there are three types of rocks: igneous, metamorphic and sedimentary. In this particular lecture, we will talk in detail about the igneous rocks. So igneous rocks are formed from the cooling and solidification of magma or lava. Means when the magma is coming out, magma is in mantle and it formed due to the heat of the core. So when the magma is coming out, it will instantly, rapidly cool down. Sometime in some case it will cool down very slowly also. So it is a rapid cooling plus slow cooling. On the basis of those, we have the many type of rocks. Okay, intrusive and extrusive. Extrusive rocks are formed from the lava, and intrusive rocks are formed from the magma. So granite, diorite, gabbro, rhyolite, andesite, basalt, all these are igneous rocks only. You have to remember that. And as the more the silica content, more the color will be light. So we will all do that in the further video. So if I talk about the formation process, so as you can see, this magma has come out. Okay, so this particular magma is called lava. Now it is getting solidified. As you can see in the diagram itself, that this magma is solidifying. Earlier it was in semi-molten liquid form, now it is getting in the solid form. So when this lava will solidify, these rocks will be called as igneous rock. And igneous rocks are also called as primary rocks. As you can see in the diagram itself, that this is the first rock that has been created, produced, constructed by the nature in our on the earth. So this is our igneous rocks. If I talk about the classification, so there are many classification of igneous rocks, like based on origin, based on texture, and if we talk about the types, intrusive and extrusive, we have already done. And properties, mineral, what are the mineral composition, what are the color, whether they are crystalline, whether they are glassy, this is the texture. That's what we are going to do today. Okay, so igneous rocks, we have already known that solidification of molten rock material, and they are categorized based on their origin, texture and mineral composition. So how we will divide igneous rocks, because there are many igneous rocks. As you can see in the diagram, that there are many igneous rocks, all are having different kind of origin, texture and mineral composition different. So like unlike sedimentary rocks are formed by the compaction. Like this is the rock, so due to the compaction, due to the layering, due to the lot of heat and pressure, what happens, our igneous rocks primary rocks has been changed into the sedimentary rocks. Also, if these rocks go into subduction, then it will be called as metamorphic, like it will change all the chemical properties, it will be turned into the metamorphic rocks. Okay, so unlike all these things, unlike sedimentary rocks and metamorphic rocks, igneous rocks originate directly from the molten material. See this is the molten material. Okay, this is the lava. So the rocks that is directly originating from the lava itself, from the molten magma itself, that is called igneous. And when igneous rocks will go into compaction, that will be called sedimentary rocks. And when igneous rocks and sedimentary rocks go into subduction, goes again back into the mantle, or as it is going into inside the mantle, inside the earth again, it will have lot of heat and pressure, it will change the properties, and that is called metamorphism. So in upcoming videos we will talk about sedimentary rocks and metamorphic rocks also. Okay, now let's take this further, that this is our type of sedimentary rocks. All these are sedimentary rocks, as you can see in the like if I say some names, then mica, breccia, shell, siltstone, mudstones, grit stones, all these are the examples of in front of you. It is the example of sedimentary rocks. Okay, and if we talk about the metamorphic rocks, the slate, the examples are slate, phyllite, schist, gneiss, hornfels, quartzites. So all these are examples of metamorphic rocks. Okay, so first of all we will talk about the properties of igneous rocks. So first property of igneous rock is that they are in the crystalline structure. As you can see, this rock is a igneous rock. Okay, and it have a crystalline structure. As you can see closely, that it have crystals. Can you see the crystals? It is a bit shiny, on the shining side. So these particular igneous rocks will have the crystalline structure, texture. How? Because of the interlocking of crystal that formed as the molten rock pools. When the molten rocks, when the molten magma, when the molten lava is cooling, then what happens? That crystals comes together, and this is how this crystalline texture comes in the igneous rocks. Second property is hardness and density. So most igneous rocks are very hard and very dense also. Dense means the mass per area, this volume will be more. Okay, if you will carry igneous rock, it will have some weight as comparison to sedimentary or metamorphic rocks. So you have to remember, most igneous rocks are very hard and they are very dense also. Density is because they have so closed, interlocked, particles to each other. Okay, third is mineral content. So igneous rocks will have many mineral contents because it is a fresh, it is a fresh lava that is coming out of the surface, from on the surface. So it will have lot of minerals. So in the diagram itself, see biotite, quartz, plagioclase, feldspar basically, and alkali feldspar. These all are the minerals that is present inside the igneous rock. These all forms basically the igneous rocks. The fourth property is that color variations. So igneous rocks color will be decided on the basis of silica. Remember, igneous rocks color will be decided on the basis of silica content. More the silica content, lighter the color will be, and less silica content, more darker the color will be. Okay, this is the thing. Okay, so tell me, rhyolite, andesite, basalt, okay, these three are the rocks in front of you. Tell me that in which rock silica content is high or silica content is low. So we can easily determine that rhyolite is having more silica content because it is in the pinkish color, more lighter way, and andesite will have less silica content, that's why it is in the darker side. That's how you recognize the igneous rocks. So at Universal Group of Institutions, we have a geography lab, and in that lab we have all the rhyolite, andesite, all the rocks, and we generally do the practicals in our academics also. It helps in our UPSC preparation, because when we see the rocks by our face to face, or we hold them in the hand, then we get to know about the texture, about the density. So you make sure you recommend your your siblings, everybody to join our institute. Okay, fine. Let's move to the third one, that this is the igneous rock chart basically, that how it is origin, extrusive, intrusive. So there are two types. Extrusive means by the lava. These are formed by the lava. So in examination question will be asked, which of the following igneous rocks are known as extrusive igneous rocks? So you have to mention rhyolite, basalt, pumice and obsidian. These are the extrusive, means these are formed outside the surface. Okay. Intrusive, like granite and gabbro, these are the intrusive. Like granite is the same granite we use generally on the kitchen countertops and all. Okay. And there are some igneous rocks that are both intrusive, both extrusive. The names are like this: porphyrite. Okay, so this particular igneous rock is both intrusive as well as extrusive. So this becomes very important for us. And what is this low felsic, high felsic? Simple is that if density is high, it will be low felsic. If the density is low, it will be high mafic. Color will be darker side. Okay. Also, we have started our batch for KS and IS preparations also. The new batch is starting soon. You should definitely check out our UCC, Universal Coaching Center, for our admission for IS and KS coaching also. And you can visit our campus as well as you can call on these numbers for further information. So seats are limited, go check it out. Now let's talk about the main types of igneous rocks. Okay. So there are three main types, or we can say majorly it's two only, but it's written three. First is intrusive, second is extrusive, third is plutonic. So intrusive rocks means thousands of years texture, means cooling time. See what is, it's very easy to remember. Extrusive means this one is extrusive, this one is extrusive. When the magma will be coming out of lava, don't you think it will cool within seconds, and sometimes it takes months, sometimes it solidify into seconds, sometimes it takes months. So that is called extrusive. So basically in extrusive what happens, that there is a lot of time, sometimes there is not lot of time, sometimes there is lot. So texture would be invisible, like we won't be able to see the crystals properly, or the grains will be very microscopic. Means if the rapid cooling will be there will be no such grains. There is no time to make the crystals. There is not much time to make crystals, so it will instantly solidify. Now, if we talk about intrusive, the grains, means the texture of the intrusive rocks will be bigger. Like you will be able to see from the naked eyes that yes, we can see the crystals, we can see easily. And plutonic will have the large grains. So in examination, question can be asked regarding the descending order of the grains structure also. So the first would be plutonic, the large one, second would be intrusive, and third would be the extrusive. This is how you should prepare for the UPSC and KPSC prelims examinations. Okay, between the lines reading has to be done. So if we talk about the classification of igneous rocks by their formation, first would be the volcanic igneous rocks or extrusive, because extrusive igneous rocks are formed by the volcanoes itself, that's why the name is. Okay, so these particular rocks form when the magma erupts onto Earth's surface, where it is called lava. Okay, and it cools rapidly. This rapid cooling often result in fine grained texture. Remember always, because of this rapid cooling, we are having a fine texture. Fine means very, like you cannot even recognize. Can you recognize any crystal here? You cannot. Okay. So example of extrusive igneous rock, like this particular rock in front of you, is called basalt. So basalt is a dark, can you see the dark grained rock commonly found in oceanic crust. So basalt will be formed in oceanic crust, or we can say oceanic crusts are made up of basalt only. Okay. Second is andesite. So andesite is typically found in the volcanic arcs, associated with the subduction zone. Subduction zone means when two plates are colliding, one plate will go down because of the high density, it's the rule. So this particular area will be called subduction zone. So this particular rocks are formed when the subduction is going on and when the volcano is getting erupted here. At that particular moment, this particular rock is called andesite will be formed. Okay. See the structure, very fine grains are there, very crystalline fines are there. Okay, you cannot even differentiate in, you have to use a microscope to see that. Okay. Second is plutonic or intrusive igneous rocks. So I have already talked about the volcanic landforms in my previous videos. Go check it out: batholith, laccolith, lopolith, okay, all these volcanic necks, sills, dikes. So all these are example of plutonic, or we can say igneous rocks only. So when magma is cooling very slow, because when the magma is coming on the surface, because of the air present, because of the like our average surface temperature of the earth is normally 20 degree, 22 degree, but the magma that is inside the earth, it will constantly get the heat. So magma beneath the surface will slowly cool. Remember that, okay? So this particular slow cooling will result in the formation of large crystals. As you can see clearly, we can see in the photo that we can clearly see this is white, this is black, sorry, and this is our yellow, orange. We can, in this particular photo, this is granite actually. These all are granites only, what we use in the countertops. So granite we are extracting from the beneath the surface basically. In this particular rock, and you see the orangish is, pinkish is there, then again the black. We can differentiate from our eyes itself. We cannot differentiate in this one. Can you differentiate here? No, you cannot, okay? So examples of intrusive igneous rocks include granite. This is the granite. It is coarse grain. Coarse grain means fine. It's not fine, it is opposite of fine. It's thicker, bigger, okay? Generally we use in the countertops, I already told you. Second one is gabbro. So this one is gabbro. As you can clearly differentiate, this particular is white, okay, this is black, this is blue, this is red. You can clearly see that which one, like you can just, these mineral contents you can definitely define that. So it's a very dense dark colored rock, often found in the earth's oceanic crust. So gabbro is also found in the oceanic crust only, okay, fine. So if I talk about the origin of these particular terms, so it will help us remember what exactly they mean. So igneous word comes from the Latin word ignis. Ignis means a fire basically, okay? Ignis means fire, F-I-R-E, fiery origin. So the ignis means fire, ignite means fire, it means it is coming from the fire, means lava itself, okay? Volcanic, what is volcano? So volcano is named after Vulcan, and who is Vulcan? The Roman god of fire itself, okay? The Roman god of fire, referring to rocks formed from the lava that erupts from the volcano, again, volcano. Plutonic, so plutonic, the name come after the Pluto, and Pluto is also the god of underworld. So Pluto is the god of underworld in the Roman scriptures. So this particular plutonic means intrusive. Intrusive means it is forming, the rocks are producing beneath the surface in the depth, like batholiths, remember? So this is called plutonic. So this is how you learn about the intrusive rocks, okay, from the ground, from the magma, while extrusive rocks from the external, from the lava itself. Now igneous rocks are formed at various locations on earth, including mid-oceanic ridges. So this is the mid-oceanic ridges. Mid-oceanic ridges means the magma is here. When the magma is coming out, lava, and we are talking about the ocean, this is the ocean surface. The moment magma will come out, don't you think it will come in the contact of water, H2O? The moment magma will be coming out, it will instantly solidify. So this particular rocks are nothing but igneous rocks itself. These are the igneous rocks, both sides. And which rock will be? Basalt. Generally in oceans, basalt rocks are formed. This is how sea floor spreads, and this is how the oceanic crust are formed. So can you see? So this is one igneous rock, this is second igneous rock, this is third igneous rocks. This is how the oceanic crust was formed. So igneous rocks helps us in the theory of sea floor spreading, ultimately how the oceanic floors were formed. So this is very important concept, and the largest, the biggest mid-oceanic region in the world is Atlantic mid-oceanic ridge, that is present in that is located in the Atlantic Ocean. This is the Atlantic Ocean, this is the mid-oceanic ridge photo from the depth of the sea. So this is how the rocks are formed, basalt rocks are formed, okay. Second example is volcanic arcs. So igneous rock, we are talking about the igneous rock where they are found. So this is the first place they found. Second place is volcanic arcs. See, this is interesting. So there is one rock, this is second rock, this is the first rock, this is the second rock. Second rock is subducting into the first rock, subductive into the first rock. So this particular zone will be called as subduction zone. Okay. Now when it is subducting, more and more molten rocks are formed and it will push upward and it will result in the volcano arc. So see, this interesting, this is our sea level. Earlier the ridges will be formed like this, and the moment that ridge, that sea mountain comes out of the surface like this, that is called volcanic arcs, and when it will calm down, it will become the islands. It will sink sometime and it will become an island. So this Andaman Nicobar of India is the example of volcanic arcs only. Okay, fine. So at volcanic arcs, two rocks are generally found. One is andesite, this is andesite, and this is our rhyolite. Now tell me, which one is more silica content? Can you tell me? Obviously rhyolite will have the high silica content and andesite will have the low silica content. That's why the color difference is. In the end, both are the igneous rocks only. Okay. So the third is hot spot, means the area where igneous rocks are found is hot spots. Example is the Hawaiian Islands, where basaltic lava flows are typical, and this is the example of hot spot. In examination also, question was asked that Hawaii Islands is the example of what? Mental plum. It is example of melted plum. As you can see that this particular, these are the volcanoes. ये सारे के सारे volcanoes है. Mauna Loa, Kialoi, Lohi. These all are the examples of what? Volcanoes. But like beneath those volcanoes, a big, like a container of volcano is present that is constantly giving them the molten magma. The lava is instantly coming. That's why this Hawaii, Maui, all these are the active volcanoes. Even today they are active because of the melted plum. This particular structure is called as Hawaiian hot spot. So Hawaii is an example of hot spot. You have to remember that. That has been asked in examination already. The fourth area where igneous rocks are found are continental crust. So this is where granite and other plutonic rocks are formed. Okay, remember that plutonic means underground rocks are formed, because granite is also underground rock only, because it is formed under the surface. So our continents are formed by the granite, basically mostly by the granite, and our oceanic crust is made up of basalt. You have to remember that. And when continental crust and oceanic crust will collide, which will go down? Basalt will go down, because basalt is having high density than the granite rock. Okay, fine. Now let's talk about the classification of igneous rocks. So first classification would be based on texture. Texture means what is the grain size, shape, and arrangement of crystals. Okay, so first, if the texture is coarse means if the texture is big, means if the crystals are large enough so that we can see from our naked eye itself, that is called our coarse grained or pheneritic texture. Okay, and why the texture is there? Because they are slowly cooling. Because of the slowly cooling, like minerals have enough time to grow into the big crystals. This is the reason why it can be asked in examination that if the magma, if the lava is cooling slowly, how come crystals are getting bigger? So this is the reason itself, that because of the lava cooling slowly, crystals have lot of time to be bigger. That is why our coarse grained texture is. Example is granite. Granite is example of coarse grained texture. Second is diorite, and the third one is gabbro. So these all are the examples of coarse grained. Like we can see the grains easily. Can you see the grain? This is black, this is silver. Easily we can find out. The second is fine grained. So just opposite of the coarse grained, that crystals are too small to see clearly without any magnification. Can you figure out anything? No, we cannot. Now the thing is that it happened due to the rapid cooling near the earth's surface. Rapid cooling near the earth's surface, that's how we get the aphanetic texture in the igneous rocks. The example of rhyolite, this is the example of rhyolite, andesite and basalt. These are the examples of fine grained texture of igneous rocks. So what happens actually exactly then, when rapid cooling is happening in volcanic environments, crystals don't have time to become big, so that's why the thinness is, okay. This is the simple reason. Third is glassy texture. So example of glassy texture is obsidian. Obsidian is a rock, that is example of a igneous rock only. So there is no any crystal, visible crystal is not there, because extreme rapid cooling means this type of texture will come in igneous rock when it is rapidly cooling, even rapid than the rapid than the aphanetic, like rapid cooling than these type of rocks. If more rapid cooling is happening, we have the glass like texture, okay. See, the reason is written here. Obsidian forms when lava cools so quickly that atoms cannot organize into a crystal structure. Means it is happening so fast that atoms don't even have the time to organize into the crystal structure. Leave the fine or coarse grains later, okay. That's the thing. Second classification is based on the composition, based on the silica content we have already talked about. So these are categorized as in three: felsic, intermediate, mafic and ultramafic, okay. So felsic will have the highest silica content, and the mafic and ultramafic will have the lowest silica content. That is the composition based of classification. We will talk in further. Third based is formation environment. So basically this is where this is whether they are volcanic or plutonic. So third classification of igneous rock is very basic, that whether it is intrusive or whether it is out. So example is granite, gabbro, andesite and basalt. The basalt and andesite is the example of extrusive, and granite and gabbro is the example of intrusive, okay. So why see, we have repeated basalt, granite so many times because 1 to 2 questions will be definitely coming in the prelims or our mains examination, definitely, because this is the basic of the earth's origin, okay. You have to remember that. So if I talk about this in detail, like this is the main category, this is the main classification of igneous rocks, like felsic, intermediate and mafic and ultramafic. So if I talk about the felsic rocks, so in felsic rocks we will have the highest silica content. That's why the color of these type of rocks are very light, sometimes nearby transparent. Can you see this? This is the example of quartz. This is the example of feldspar. These are the minerals basically, okay. So these type of rocks are, rich in the this potassium, aluminium and sodium, and these type of rocks will have more than 65% of silica content. So in examination question can be asked that if the silica content in a rock is more than 65%, which type of rock is this? Options can be felsic, ultramafic, mafic, all these, okay. Intermediate, fine. So generally the appearance of these particular rocks will be white or light gray or pink in color. As you can see here also, it is a pinkish and it is totally whitish, okay. Now second rocks are intermediate rocks. So silica composition will be lesser than, what is the lesser than? 52 to 65%. Can you see? If it is more than 65%, it will fall under felsic category. If it is between 52 to 65 category, it will fall under intermediate rocks. This is how you should learn. And the next mafic and ultramafic rocks will be having less silica content. So a question can be asked regarding ascending, descending or match the following, definitely, okay. Now silica content is there. If we talk about the rocks, so diorite and andesite is the example of intermediate rock, because the silica content in these rocks are around 52 to 65%, okay. Third is mafic rocks. So mafic rocks, see again 45% to 52% silica content. Example is basalt and gabbro. This is the basalt and this is our gabbro. So these are having darker colors because of low silica content. Low silica content. More the silica, more the fairer the rocks color is. And these will have denser, means mafic rocks are more denser than the felsic rocks, you have to remember. So silica content, if the silica content is high, color will be light, also density will also be low. That has to also be taken care of. And in mafic rocks you will find lot of iron and magnesium also. Okay. The fourth composition is ultramafic rocks. So ultramafic rocks will have the silica content less than 45%. Less than 45%. So we came from more than 65 to less than 45. These minerals will also have high, like in iron and magnesium. Okay. So the example can be see the appearance of these rocks. These are very darker rocks because of the low silica content. This is our peridotite. This is the peridotite rocks, and this is our dunite. Okay. Generally these are black plus green, as you can see in the example itself. So this is all about the igneous rocks, students. I hope you like the lecture. If you do like, just make a thumbs up, give a thumbs up, write in the comment box your feedback, your queries, your questions, or share with your friends also. Okay. In upcoming videos we will be talking about the sedimentary rocks as well as the metamorphic rocks. So there is a question in front of you. It is the UPSC question that describe the characteristics and types of primary rocks. So basically, first of all, we have to know like what primary rocks are, right? So till now, like if you have reached till here, then you might know that igneous rocks are called as the primary rocks. Okay. So I will wait for your answers in the comment box. See you in the next one. Till then, like, share and subscribe. Thank you so much.